So previously we went over the shapes of molecules that did not have any lone pairs around the central atom, and now we're going to be talking about the shapes of molecules that have lone pairs around the central atom. So let's discuss what exactly a lone pair is. A lone pair basically refers to a pair of electrons around the central atom that are not involved in bonding. So for example, if you have water over here, in this case, oxygen has 6 valence electrons and only 2 of them are going to be involved in bonding. So oxygen is going to have 2 lone pairs. These are the 2 lone pairs that you have. Now these 2 lone pairs are going to be generally larger than those containing bond pairs. This is because these are going to take up more space around the central atom. And because of that, they're going to be attracted to the atom's nucleus. And they're going to have a greater repulsive effect on the pairs that surround the central atom. So in this case, what's going to happen over here is, now over here, this diagram that I've drawn, this is completely straight, right? But because of the fact that these lone pairs are going to have a greater repulsion, this molecule is going to become what we call bent or V-shaped. And in this case, this angle was 180 degrees, right? If you made it completely straight. Now you can see over here that the angle over here has decreased, right? So the rule of thumb over here is that for each lone pair, you're going to subtract 2 degrees. So in this case, we have 2 lone pairs. So we're going to subtract 4 degrees, and the value of the angle should be approximately 105.5 degrees. Now the actual value in this case is going to be 104.5 degrees, which we're required to learn for our syllabus. And the reason why the angle decreases is because lone pair repulsion is going to be greater than bonding pair lone pair repulsion, and the bonding pair repulsion is going to be the least because the bonding pairs are also closer to the nucleus, so the repulsion between them is going to be lesser. And the reason why we used 109.5 was because in this case we have 4 regions of electron density. This is because over here there's one hydrogen, another hydrogen over here. So these hydrogens correspond to 2 regions of electron density, and the lone pairs are also going to classify as another region of electron density. So when we look at regions of electron density, we're going to look at single bonds and double bonds and triple bonds as one region, and lone pairs are also going to be counted as one regions. So normally when you have 4 regions, the bond angle is going to be 109.5, but in this case, because lone pairs are present and because of lone pair repulsion, the bond angle is going to decrease, and we're going to go with this rule. So besides bent and V-shaped molecules, we have trigonal bipyramidal shapes as well. So in this case, the example that we're going to be looking at is going to be ammonia. So this is the dot and cross diagram for ammonia. Like we did before, the first thing that we're going to be doing is we're going to be making the dot and cross diagram. So in this case, the dots represent the electrons of nitrogen and the crosses represent the electrons of hydrogen. Now, since ammonia is going to be in group 5, it's going to have 5 valence electrons, right? So over here, one pair is going to be a lone pair. So in this case, now we're going to count the region of electron density. So we have 3 hydrogens and 1 lone pair. So this corresponds to 4 regions of electron density. Which is 109.5 degrees. And since there's one lone pair over here, we're going to subtract 2 degrees and we'll get 107.5 degrees, which is going to be an approximation. The actual value for this is 107 degrees, which we also need to learn. So if we make the 3D bond notation for this, we're going to have nitrogen over here. We're going to have one bond which is laying completely flat. As you can see, this bond over here is coming straight at you. So we're going to have a wedge over here, and this bond is going away from the camera. So we're going to have a dotted bond over here. So this is going to be the 3D notation for trigonal bipyramidal shapes. Now we're going to look at the bond angles in ions. So in this case, we have NH4, which is ammonium. Now nitrogen is going to be in group 5. So it's supposed to have 5 valence electrons. But since the charge over here is plus, that means nitrogen has lost 1 electron. So this actually has 4 valence electrons. And since we have 4 bonds over here, there are no lone pairs around this atom. And there are 4 regions of electron density correspond to 109.5 degrees. And the shape over here is going to be tetrahedral. So with regards to shapes that have lone pairs in them, usually in the marking schemes they give a range for that. So if you write 107.5 or 107 or anything like that, both of these are going to be marked correct because there's going to be a range in the marking scheme.